Yeah. Okay, so last time when we discussed with Lamar, he went over some of the campus design stuff. We're going to go through one more day kind of talking about this and deal with the 3D piece that he came up with, dealing with that, how much bleed do you get through floors. He actually kind of answered it two ways if you were watching. At first he said, oh, well, you don't get much. Then he said, well, we offset APs from floor to floor. And when I was talking with him a little bit later, they do what is the common practice, which is with current systems, basically you set them up and you say, AP, you choose the channel, or actually controller, you choose the channel. Now with 3 channels, almost always you're going to see one of those patterns we're picking up, and we're doing it manually so that you'll understand what's going on with it. But when we do that offset, like he talked about, what they're doing is keeping it from bleeding through the floors directly on top of another AP. So we're going to go through one of these today, kind of talk through it, see what we need to do. Wednesday, I'm going to introduce a problem which you're going to recognize, where I'm actually going to give you the Curve Center as it stands with their design considerations for this. I'm going to go ahead and treat it as a project, although it's going to be what we're doing here. This level of stuff, we need another project score, so I'm going to go ahead and let you do that. Bring it to class Friday, because Lamar's going to come back in, and we're going to compare what you guys came up with what they ended up doing. Okay, so thought that would be a good way to kind of bring this full circle and around. So with that in mind, let me go ahead and see, don't want this. Yeah, this is what I want. I have 2 variations on the problem. We'll probably go through both of them today. Okay. Also, one note of business that I forgot to mention. The trip to CSI is a week from tomorrow. I'm going to go ahead and put a sign-up sheet for you to let me know if you're going. It's just so we know we have enough cars. You are welcome to drive on your own if that's more convenient for you, but if you're planning on us getting you there and back, we need to know if you're going, so we don't show up with 20 people and 10 seats. So anyway, I'll get that up. Okay, so let's take a look at the situation here. This is an office building, 5 floors. We have 20 users per floor. We are talking about 2.4 gigahertz. Let me get my cheat sheet out here so I don't forget something important. There we are. Getting a lot this semester. Nothing like a little lightweight evening reading. Okay, basically we're talking about the floors are 100 feet square, so each floor 100 by 100. Design Network provides coverage for users on each floor at any given time. There are about 40 users on the first floor and 20 on all the others. Okay. Same rules as last time. APs have adjustable power, may be mounted anywhere. This says in the park boundary and the building boundary. And the antennas are omnis. So the questions I have for you, and I would like you to pair off and go kind of talk through this. Omni antennas. How many APs? Where are they located? What channel? And then be prepared to discuss your design considerations. Actually, if you're looking at the notes, I actually phrased that a little differently, but that's my goal in this. So if you would, pair off however you want. And this one shouldn't take a real long time, but be sure you talk through the considerations for each one. I'm going to have to jump out of this I'll leave it up and get it. Okay. Working on this problem. It's a 5-story building, first floor, 40 users, 2, 3, 4, and 5, 20 users, 2.4 gig, omni antennas. These are the questions you need to do. Jump in with one of these groups. We're going to take a few minutes to discuss it. Be prepared to discuss design considerations. Those of you at home in the online class, what I would like you to do is, while we're doing this discussion, go ahead and work on it yourself so that you keep the same pace as the local class. We'll be going through the discussion past that. That doesn't look like it took long. So talk to me about this one. How many APs do we need, first off? Yeah. Okay. Line them out for me. Okay. 2 on first floor. Why? Yeah, more users. And then floors 2 through 5, 1 AP per floor for users. Do we have to worry about coverage? Not with a 100 by 100 room. Typically not. I realize after listening to Lamar, and I've got to update my lecture on this, the newer APs, particularly the controller-based ones, and he is saying that where we are on campus is actually kind of straddling this line right now. The older APs, that 25 users per AP is a good number. For the newer APs, they have a lot more power. And so they can support, 100, 150 users, depending on what the users are doing. His comment, and I want to follow up with him on this on Friday, but his comment was you kind of had to watch. If it's just checking email or something like that, obviously you can support more. If lots of people are streaming the dorms, for example, then you don't want to load them that high. It's pretty straightforward stuff. But with 100 users per AP, this gets somewhat easier when we get in denser solutions. For now, let's stick with our 20. Since my lectures on this are based on the 25, let's go ahead and stick with that number. The same concept works with the larger numbers. You just have more users. The math works a little differently. Okay, so how would we do channels? 111 on bottom. Okay, so 1 and 11. Okay, 6 on the second floor. 1, 6, 11. Do I get on my floors? 1, 2, 3, 4, 5, yeah. How would I physically mount the ones on the first floor? First off, given just the information I gave you here. Probably put them right together, right in the middle. So in other words, 1 and 6 co-located. We're trying to cover the whole floor. Okay. Why? The only reason we have 2 is because we have more users than we can support with 1. Now, if I had thrown in, a diagram that showed a waiting area or something where a bunch of those users were, we might put one directly on that and the other one more towards the back. I didn't give you enough information to make that call. So, absent that, we just mount them right together, side by side. Okay? Let's complicate our lives a little bit. You knew I was going to do that. So, okay. Now, same idea, same building as a matter of fact. Now we have 40 users on every floor. Okay? And the antennas are still omnis, and we're going to answer the same questions. I just want you to think through how would you do 40 users. So take a few minutes and go through that. Obviously, the channel distribution is going to change. Again, if you're working through this in the online class, watching the video, work through it at our pace here. The discussion will be prepared to compare your decisions versus our discussion and kind of see if you come up in the same areas we do. It's 5 o'clock in the morning. What do you think the answer is?
It's acceptable. But if you come and wake me up at 5 a.m., I might be able to do that. Yeah.
No, I think my car is broken. Okay, so what do you think? 5-story building, 40 users. How many APs do we need first off? We need 10, right? 2 per floor. Now the big question, how do you assign channels? You might want to throw one out there? 1 and 6 on the bottom floor.
We put ours on separate ends.
Hold that thought. Okay, you put them on like, well, okay, let's go ahead and deal with it. So in other words, for a 100 by 100 floor, 100 foot by 100 foot floor, where did you put them?
We were kind of different plane of view on that, but essentially
Okay.
separate sides of the room.
Okay. Okay.
Like the way I drew it was kind of just like a rectangle of each floor, and we have like one AP on one side.
So
This was just
Like-
so when you
here and here? Okay.
in thinking that, I was just, as it goes up, I feel like we would be able to separate the ones on separate sides as you go up.
Okay. Okay. So what did you do on floor 2? I'm sorry? 6 above the 1. Ah, okay. So you just, so is this what you did? 6, 1, 6, 1, 6, 1, 1, 2, 6, 1?
Similar, but we used 1, 6, and 11.
Okay. So tell me where you used 11. Oh, okay. Okay. So 11 here. I need another color. 11 here. 6 here. Okay.
And then above the 6, you just wrote this one.
Okay. I see what you're doing. And then the 1. Okay. So you did the 1, 6, and 11 up this way. Okay. 6. And then this would be 11.
Actually, where you put the 6 was an 11.
Right there.
It's kind of like a, I don't know, I guess it's not weird. And then the 6 above the green 11.
Right there. Oh, 6 here.
Yes. And then where you just put 6 was 11. And then 11 in the top corner. Does that make sense?
Is that right? Is that what you did? Okay, let's see. So why this pattern?
Just, okay, essentially, so in hopes of putting the APs on separate sides of each floor and then going up, we hope to stagger it in ways that the channels wouldn't go up here. So we made sure that the 2 channels were the same on each floor and that they wouldn't touch each other on half of the building.
Okay.
So you split the building down to half, this way, or on the same.
So you treated it basically as 2 buildings that were close to each other. Okay. Questions from you guys? Okay. Before we go any further, what did you guys come up with?
We did 1 AP in the middle of each floor, and then 6 and 11 alternating our way up.
Come on over here. Camera. Ah. I'll stick here so where they can still see it. Okay, so 100 feet, 100 feet. How did you do it?
We put an AP in the middle of each floor, and 6 or an 11 alternating all the way up.
AP in the middle of each floor?
Yeah. And then off, staggered off to either side was another AP that was on channel 1.
On channel 1?
Yeah.
So where? Like
Yeah, probably just to the right of the 6.
like here? Okay. Then so going up the list then, did you have a 6 on each floor?
We did a 6 and then 11. We alternated.
Okay, so 6, 11, 6, 11, 6, 11.
And then
Or-
alternated, we put the 1 on either side of it.
Let me transfer this over. 11, 1. I don't know why I'm even doing 2 colors since I don't have 3, but I've already started, so I'll be consistent. Okay. Okay, so you guys did for the middle one 6 or 11, right? Okay, like this? Okay, and then what would this be? 1? Oh, okay, I see what you're doing. Be 11?
No, be a 1.
Be a 1?
And we just, basically we're trying to cover like half of it.
Oh, okay, like this?
Yeah.
Ah,
Just to cover users.
okay. This is all going according to my plan. Oh. You've got, what's the as we're going through this, with the restrictions I put on your solution, what's the problem?
We don't have much power.
We have one of the oldest problems in the world. Did I get that right? First off, let's make sure. 6, 1, 111, 6, 1, 111, 6, 1. Okay. We have one of the oldest problems in the world here. With the restrictions I gave you, we have a square hole and a round peg, or a round hole and a square peg, depending on which way you want to do it. The combination doesn't work either way. You can do it no matter how you set it this way. You're probably going to have some interference. And the reason is, how does this omni antenna actually radiate? If we take this antenna that we're looking at this way and we turn it up like this so that we're looking at the side of the antenna, how does it actually radiate? What's the pattern? Yeah, it's an annulus. In other words, this is a donut with the antenna sticking up through the middle of it. So we do have more radiation in the azimuth direction, in the direction I can point as I turn around if I ignore up and down. And we're counting on floor attenuation with any of these plans. We're counting on there being enough attenuation between floors to make this work. And you know, probably that's an okay assumption. Lamar actually addressed that. You remember when he was talking about the dorms? He did, let's see. He actually did something a little closer to this, except he did 1, 6, and 11 on each floor and offset them. So I'd have 1, 6, and 11, and then I'd have 1, 11, 6 shifted 10 feet or so. And so he's counting on that attenuation as well. Now, let me give you the option of using, let me just say that you can use an antenna. It has to have a reasonable pattern. You can't find an antenna that radiates square, okay? I don't know of one. If you can use, well, let me give you this. You can use a 90-degree sector antenna. Now, we talked about directional antennas. The actual term I'm going to start using is sector antenna, because basically a sector antenna is a directional antenna that has a particular radiation pattern in vertical and horizontal. This is the horizontal beam width. So we're talking about 90 degrees. Vertically, sector antennas have a fairly narrow pattern. Okay, maybe 10 to 15 degrees. Okay? So what have I just given you in terms of solving this problem? giving you a way to keep the energy where you need it, which is one of our fundamental questions. Where do I need the energy to go? So with that in mind, work back through this problem using a sector antenna. And then I'm going to throw an alternate at you. Oh, good. Oh, good. Now it decided to track me. Me too. I started my first reading for pleasure book in months over the weekend. I really wanted to stay home reading today. I shouldn't have. I just indulged myself. Yeah, you wouldn't have minded if we stayed home. Tell you what, 3 weeks' time, we'll all stay home. How's that? That's my plan for Thanksgiving, actually, is to read books that have absolutely no redeeming quality whatsoever. Tom Clancy and Clive Cussler, what can I say? Very forgettable, predictable from the first 4 pages. I love them. Pardon?
I'm going to propose for my next night.
Ooh.
Pretty sure she won't say no.
She see it coming?
Well, we both went to ask her that last weekend.
I'd say she sees it coming.
She probably sees it. I know all of her friends are completely different dates than I'm going to do it on those, so maybe there's a little surprise. We're done it this weekend, but I don't have a ring yet.
Excuse me.
Well, instead of being directional antenna, it's like an antenna that can be sent in a specific area, and in which the area in which it was sent in from it's like, help keep it on the floor better. That's what I understand. That's how it works, right?
I'm sorry?
The antenna that we implemented in this time, the sector, it essentially just makes it where it would be like focused like down the hallway instead of
Yeah, if you think through the angles I gave you, look in this room. This room's, what, 30 feet by 40 feet roughly, so a little larger than double this room. 10 to 15 degrees up and down, 90 degrees in azimuth, horizontally, yeah, I'm flapping. 90 degrees in azimuth over here, come on. Follow me over here. Battery must be getting low in this thing. There we go. I wonder what that looks like on the recording. So, when we do this, how would you deal with the floor? Would you do anything different? Okay. And what would they get you? You've got complete coverage of a floor. I said you can't use an antenna that radiates in a square pattern, but you come pretty darn close by doing it that way. Because what you're really doing then is you are, instead of trying to fit two offset, you're offsetting APs, trying to keep them from interfering with each other, going floor to floor, And in this case, by using an antenna that has a narrow vertical pattern and a 90-degree horizontal pattern, what we can do is this sort of thing. 1 and 6, say. I figure that's a combination that shows up somewhere in your plan. Then on the next floor, what would I do? Yeah, I might use 11, 1. You know, I would honestly try just doing 1, 6 if I'm counting on the floors providing that isolation. Let me give you one other thought here. First off, let me bump this up to 70 users. Okay, what have I just done for the number of APs? Okay, now, and yes, I'm walking you into a solution I want you to see. Now, I'm going to give you a sector antenna. Remember, that's one that we've defined kind of broadly, pardon the pun, kind of broadly to have an azimuth pattern that is fixed across whatever we state as the angle here, and a fairly narrow vertical pattern, except I'm going to change this to 120 degrees. Okay? 70 users, you can use 120 degree sector or omnis. You've actually seen this solution a lot. Okay? Have you ever looked at a cell tower? What's the shape of the top of most cell towers? Mm-hmm. Come here, come here. Now, we have some guys in the online class that work in the cellular industry. I realize I'm playing fast and loose with current technology. Okay? Give me a moment. The reason you deal with this, cellular, of course, as we've defined, is a way of having coverage areas that overlap, and we take advantage of that overlap to allow an intelligent network to change users from one cell to the next so that we can manage loading. Right? We can provide mobility to users. What we do with sector antennas, instead of making the cells in that hexagonal pattern, what happens if I draw, oh great, here's John going to try to draw something. What happens if I take a hexagonal pattern and I cut it into 3 pieces? Hexagons, how many sides? 6. Yep. Okay. So if I do that, what's the angle between here? How many degrees in a circle? 360 degrees. So a hexagon means I'm looking, each of these faces covers 60 degrees, right? See what's happening? Here's what happens with our cellular pattern. This is where I really do need that third marker. See our area of overlap? I can apply that to this solution. I'm not saying it's the only way to do it. I'm saying it is a way to do it that solves several problems. If I take this square room and I build okay, what am I going to do the next floor up? Oops. 116, right. What am I going to do the next floor up? Remember, these antennas are very narrow vertically. It's a way to do it. My point in walking you through all of these is you can't just think power. Power is important. You know, power is directly how we overcome path loss. It's not the only way. You know, if we turn up the power, we start with more power, therefore the same path loss doesn't drop my receive signal as far. We're back to that path loss equation. The other way I can deal with it is to use antenna gain, like we did in our equations. You know, I had you build fixed paths, and I started moving things further and further apart so that you had to use antenna gain to make that path work. Okay. Now we're looking at antenna patterns another way. This is how I can keep energy from going somewhere instead of forcing it across a path to increase gain. I'm going to use the antenna pattern to keep energy away from another area. Knife cuts both ways. Okay. So my point is, when you're looking at these kind of solutions, remember that you have power as a variable, you have antenna pattern as a variable. Look where your energy needs to go. It's probably the most overlooked solution piece. Because everybody thinks, oh, I need to do omnis. No, you don't. When you get into big box stores, I think Abe mentioned this in the first module, you go into a place like a Walmart, like a Lowe's, like a not an Office Depot, anyway, one of those big places. Think about how the product's laid out. They have long aisles of stuff. Now, in some cases, in fact, I think the Walmart here in town and Lowe's here in town actually does put APs up near the ceiling, and that's how they do it. In other places I've seen, they will take an antenna similar to this, although a narrower pattern, maybe 40 degrees or 30 degrees. They'll actually mount it on the wall at one end, shooting down an aisle. And I'll do 1, 6, 11, 1, 6, 11, depending on what load I need. And I've got good coverage. Okay. I've never seen a problem where there was just one solution. And so you have to think through, what are you trying to accomplish? Where are your users? How much data do you need to deliver, which directly translates into how much signal do I need to deliver? And therefore, where do I need my energy to go? That's where my users are. How much energy do I need to deliver, and where do I need it to go? So how much power do I start with? That's a radio choice. We don't have a lot of choice in that. We are legally, on almost all the frequencies you guys will use to do this, we are limited to a maximum of 1 watt. Typically, you're going to be using half a watt or even 1/10 of a watt. Most home APs use 1/10 of a watt. Okay? So your power can only do so much. Your real control is choosing the antenna and choosing the pattern that accomplishes what you need. So be sure you think through that as you look at problems. Okay? What I want to do for Wednesday, let's see how our time's doing here. Yeah. What I want to do for Wednesday, Lamar sent me the diagram for the Curris Center. I will put that up so that you can kind of look it over. I'm not asking you to design it between now and then. I'll go ahead and post the entire project. We'll discuss it fully Wednesday. I'm not going to give you a solution. I'm not going to point to a solution. We're not going to do this completely. I want to talk about the issues involved, and then I want you to come back Friday with a solution designed for that. You're not trying to guess what Lamar did. You're not trying to guess what I would do. You're applying these thoughts and coming up with your own solution. Our goal Friday is not going to be to point out where you were wrong. It's just to look at your solution and look at the one they implemented. You might come up with a better one than they did. Okay, so that's the way I want to look at this. It's a pretty complex environment. Some interesting things going on with that building. So, okay, we'll see you Wednesday. Watch the announcements on the Canvas page for the sign-up sheet for Paducah CSI.